Now, the reason why you need to be able to do permutations, combinations, and counting items in an event is that when you're looking at this type of stuff and you're going into the realm of probability, you need to be able to look at all of the items in a set and work with it. And that's where permutations, combinations, and the multiplying choice effect actually come into play. Okay, so today we'll be talking about theoretical and experimental probability. Okay. Alright, now probability is actually a really cool thing. Probability is actually finding out the chances of something happening. Okay, now the probability of success, and let's use just S for success, is equal to the total number of successes divided by the total number of outcomes that could possibly happen. Now, if I also wanted to find the probability of failure, which would technically count as success because I'm looking for a failure, okay, I would take the total amount of failures and divide it by the total amount of possibilities happening. Okay. Now the really cool thing, and the reason why I write it out that way, is that helps me with odds. Odds is actually the probability of success divided by the probability of failure, which is equal to this little confusing conundrum, S divided by T divided by F divided by T, or divided by T, yep. Okay, which if you multiply by the reciprocal, you should get S divided by F. So it's the successes divided by the failures. And that's the beautiful thing about odds and probability, that they're really closely linked. So that's the really cool thing. Okay, so odds and probability. Now, experimental probability is what happens if you actually do an experiment. So if you were to, for example, sit there and flip a coin 50 times, you would record your probability of what that coin did flip. Okay, so if you were flipping it 50 times, 50 total times, and 30 of the times you got heads, so 30 heads, that means you got 20 tails. Okay, your probabilities would be different, so from what you would expect, and I'll explain that in a sec. So experimental, there we go. Experimental is where you just actually conduct the experiment and then you calculate your probability based upon that. So the probability, we would say the probability of getting heads would be 30 divided by 50, which is 3/5. So it works out pretty simple. Okay, and then the probability of getting tails would actually be 20 out of 50, which is equal to 2/5. Okay, so that's experimental right there. Now, the difference between that and theoretical. Theoretical is a lot of thought experiments. So I'm flipping one coin, and I'm thinking about what the possible outcomes could be. I could either get heads or tails. Okay, so heads, tails. Okay, all right. So there's two possibilities. So the probability of getting heads is 1 out of 2. Let's go back and capitalize that because that should be capital head. And the probability of getting tails should equal 1 out of 2 for that possibility. Okay, now here's the cool thing about probability when you work with it, whether it be experimental or theoretical. When you add up these end results, and this is of all situations, I'm just using one coin as the beginning of all of this. Okay, the total solution should add up to a totality of 1, which also represents 100%. So if we represent these both as 50% and 50%, right here, obviously those will add up. This one will be 60% and this one will be 40%. Okay, so these should add up to a totality of 1 or 100%. So that is the biggest thing that you guys need to actually come up with. Okay, all right, so just to recap, probability is the chances of finding something. Odds are just the probability of success divided by the probability of failure, which is just success divided by failures. Okay, there's a difference between experimental and theoretical. Theoretical is a lot of thought exercises, what could actually happen. Experimental is what actually did happen. So those are huge parts. Okay, now the outcomes that could possibly happen, we would also call this sample space. So outcomes and sample space are very closely related. Okay, all right. Now, interesting thing, and I did kind of skip over this definition in the beginning, is the definition of an event and a complement of an event. Okay, so the probability of, let's say, rolling a 1, if we're rolling dice. Okay, and if you think about that, we could go 1, 2, a 3, a 4, a 5, or a 6. Okay, so the probability will actually be 1 out of 6. Okay. Now, if I wanted the probability of a not 1, okay, I would seriously go 1 minus the probability of a 1, okay, which would be 1 minus 1 6, which is equal to 5 6. Or you could actually just replace that with the probability of either a 2, a 3, a 4, a 5, or a 6. Okay, that's another way to actually do it. But this is called the complement. And the complement will always be subtracted from 1 because the complement is everything else that isn't part of the probability we're looking for. So the complement of finding tails is the probability of getting heads, which is 50%. So since that's 50%, the complement would be 50. It's whatever combination adds up to 1. Or 100%. And so the best way to find the complement is to take the probability you already know and subtract it from 1, and thus you'll be able to find that complement probability really, really fast. Alright, so the beautiful thing about probability is this is just the beginning of just working with all this stuff and just working on amazing stuff about chances and stuff. So, once again, please take your time. Biggest thing I ever learned from my professor in college about probability was make sure you take time to write out your sample space. If you do that, like for example, that's why I practice writing it out here and here, you should be totally cool with it. Just realize that if you include multiple events, we'll talk about that next, but you have to account for a much wider range. So sample space is hugely important when you're talking about compound events. All right, that's it. We'll talk to you later.